Okay, you have the exercise 4J question 3. Okay, verify Gauss theorem. Just now meta you have used a Gauss theorem, and then now using the Flux integral without using the Gauss theorem, f dot at ds, they use the sigma. Okay, where the sigma is the surface. Okay, here x0, x1, y0, y1, z0, z1. Okay, and then the vector f is actually your vector f 4xz minus y squared minus yz. So you have to break the surface, okay, into 6 surface. Let's say the surface 1, let's say is z equal to, okay, let's say z equal to 0, where your unit normal vector is negative k. Negative
So,
k.
doctor, that part we need to assume.
Not assume it is true.
Oh, it's true.
Assume which one is S1. The first one, the second one is up to you. As long as you
Um,
break it into 6 surface.
that let
Ah,
the negative
S1
k.
is whether it's a Z0, Z1 up to you. Doesn't matter. As long as you later on you add up 6 surface there. Okay. Let's say you want to let surface 1 is Z equal to 1 or Z equal to 0. Doesn't matter. As long as later on you add up all the surface there. Okay, and as what we explained just now, where is it? Yeah. Okay, Z0 on the floor, flowing out, so the n will be negative k. N is negative k. Then you do, okay, the evaluate the, you evaluate, okay, surface 1 first, okay, f dot n d s, okay, so this will become r1. F is 4xz I negative y squared j y z k. So negative k, so mean component I is 0, component j is 0, component k is negative 1. So this become dA over R1. Okay, R1 is, okay, on your xy plane, because Z0 on the xy plane, because each, okay, your surface is bounded, okay, by x0, x1, y0, y1, z0, z1. Okay, so then you do the dot product first.
Doctor, this part I don't understand. How the zero zero negative one, doctor?
Mm, this is 0i plus 0j minus k. Nah, this is another way to represent the, okay, the vector.
Okay, okay.
Then you have to z0. You have the, okay, surface, okay. Let's say you have a, okay, you take a cube there flowing outside. So, okay, your, okay, in the xyz direction, you have the ijk, unit normal vector ijk. So z0, okay, the, okay, flowing out, okay, z0, the floor, the floor unit normal vector pointing down, so negative k. Z1 pointing up, positive k. So like in the lecture note, same thing. 0 0 negative 1. Then do your dot product. So component ij is 0, then you just left, okay, component k, so you have negative yz. So you have negative yz dA. Okay, and then on z0, your dA is actually on the xy plane. This is x. This is y. Yeah. This is 1. This is 1. Okay, it's a square. So you can 0 to 1, 0 to 1, negative yz dy dx. Okay, and here no need no need to evaluate because on okay, the first surface. Okay, let's say I prefer to use s. I use s. Easy. Okay, the first surface s1, 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 z equal to 0. So when you plug in z equal to 0 here, so you get 0. So okay, the first surface you get the answer is 0. Okay, and then you do for surface 2. Let's say surface 2 is z equal to 1. So n is positive k. And then you repeat the process. Okay, S2 f dot n d capital S. This is a R2 for xz I negative y squared j y z k dot with 0, 0, 1 dA. Okay, and then you get the double integral, okay, over region R2. Okay, doing the dot product because component ij0 is just left component k times k, I get yz dA. Okay, and then here S2 z is 1, z is 1. So it become R2, substitute z is 1, so y dA. Okay, and then on z equal to 1, z equal to 1, the projection still same thing. When you press it, okay, the projection you look at here, this one. Okay, z equal to 1, when you press it, you will get on a xy plane. Xy plane still a square where x from 0 to 1, y from 0 to 1. Okay, then you just integrate 0 to 1, 0 to 1, y dy dx. So integrate y, you have y squared over 2. I factor out. And then, plug in 1, you will have, half 0 to 1 dx. So you have half, this is x. Okay, we plug in 1, you have 1. So it left half integrate 1 dx. So integrate 1 dx, you got x. So plug in 0 to 1, you have half. So the first one, the surface 1, the Flux integral is 0. Surface 2, the Flux integral is half. Okay, and then do the third surface. Okay, the third surface, let's say S3, let's say is x equal to 1. So the n is actually negative uh, x0 n equal to negative I. Yeah, look at here. N0 is a wall in front of you. So the unit normal vector that normal to x equal to 0 will be negative I. Then repeat the process. So you have to do it 6 times. So this is S3 f dot n ds. Okay, plug in, this become R3. Plug in the f is 4xz I negative y squared j plus yzk dot with unit normal vector, in this case is negative I. So component I is negative 1, component j is 0, component k is 0. So dA. Okay, doing the dot product, you have only component I consists of value. So it's negative 4xz dA. Okay, on surface 3 x equal to 0. So that's why the integral, okay, the third result you get 0. Yeah. So surface 1, the Flux integral gets 0. Surface 2, the Flux integral get half. Okay, surface 3, the Flux integral obtain 0. Okay, and then do for S4, where x equal to 1, n is positive I. S4, so f dot n ds, so this is R4. Okay, repeat the process, just change the unit normal vector. That's why without using Gauss theorem, it's tedious, and you got to do it 6 times. So now this is 1, 0, 0, dA. Okay, doing the dot product, okay, you get 4xz dA across region R4. Okay, so on surface 4, okay, x is 1, so you get this is 4z. Okay, surface S4, look back here. Okay, surface S4 is x equal to 1. It's a wall, okay, at the back here, this one. Okay, so when you press it, the projection is on, okay, this is a x surface on the yz plane. Okay, the surface, okay, x equal to 1. When you press it, you get the wall in front of you is actually the yz plane, because this is x, this is y, this is z. So x equal to 1, okay, the front wall, you press it, you will get zy plane. Okay, your projection is on actually zy plane. Okay, this is y, this is z. So you use dz dy. Okay, z from 0 to 1, y from 0 to 1. Oh, then so integrate 4z, you have 2z squared 0 to 1, and then dy 0 to 1. Okay, okay, you can go to author to do your quiz, okay, and then submit it by 11. Okay, I will continue record, okay, and then you can watch it later on.
Okay, doctor.
So
Okay,
this one,
doctor.
yeah, you plug in this one, you have 2 dy. So you have got 2y 0 to 1. Here we got 2. Oh, answer is 3 over 2. 2.5. Okay, never mind. We check. Okay, and then the S 5, let's say is y0 n equal to negative j. And then the Flux integral f dot n ds s number 5. Okay, you may leave the Google Meet. Okay, so the f is 4xz then minus y squared z, and then yzk dot with the unit normal vector now is 0, negative j, so 0 dA over region 5. So okay, only component j consists of values. So negative y squared z multiply negative, so become y squared z dA over region R5. On surface 5, okay, y equal to 0. Because here, plug in y equal to 0. That's why the answer is 0. Okay, let's look at the surface S number 6. Okay, S6, y equal to 1. So unit normal vector n is positive j. Then the Flux integral f dot n d capital S across surface S6. So you have 4xz minus y squared zj plus yzk dot with 0I plus 1j 0k dA over region R6. And then doing the dot product, is only component j consists of value, so you get negative y squared z dA over region R6. On x6 y equal to 1, here plug in y equal to 1. Then we get negative z dA R6. R6 is y equal to 1 in the wall. At your right hand side, when you press it, you will get the zx plane. You get the zx plane. Mean the projection, you will obtain the zx plane. This is x, this is z, where, here. So that's why you can put up,
Doctor,
yes,
the equation is not negative y square only. Why y square negative y square z?
now here, negative y squared z multiply 1, doing the dot product.
No, no, no. The initial equation is not only negative square.
Oh, 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 without z. Okay, sorry. Thank
So
you.
the upper one S5 also wrong, doctor.
Okay, thank you. Okay. Uh,
Hey,
okay, so S5, because Y 0. So answer say got 0. Okay, so S5, is there any mistake on top? Okay, this one correct. Mm. So S5 because negative y squared times negative 1 y squared. Substitute y equal to 0. So S5, flat integral on S5 still get 0. And then on S6, negative y squared. Substitute y is 1, so you have negative. Negative 1 dA, where the projection on y equal to 1, is a wall at the right hand side. Press it, you will get zx plane. So zx plane. So it's still a squared. So the limit 0 to 1, 0 to 1. So negative 1 dz dx. We use a vertical dz dx. So integrate negative 1 respect to z, you have negative z 0 to 1 dx. So the answer still get negative 1 dx from 0 to 1. Then integrate negative 1 respect to x, still get negative x. So plug in 0 to 1, you have negative 1. Now add up all the answer. Means the Flux integral on s f dot n ds. So you add up from s1 f dot n ds, s2 f dot n ds, plus s3 f dot n ds plus s4 f dot n ds, plus s5 f dot n ds plus s6 f dot n ds. I'm not mistaken, the first one, the first surface is 0. Second surface answer is half. The third surface is 0. The fourth surface, I'm not mistaken, the answer should be 2.
Two, doctor.
2. The fifth is 0. The sixth is 1. So add up 3 over 2. Right. 2. So which is tally with what you method that you obtain using the Gauss-K theorem just now.
Okay, doctor.
Okay, then you may do your quiz.
Okay, doctor. Thank you.
Yeah, where is it just now? The picture that I saved just now. Where did I save it just now?